Today we're starting Chapter 8, which is all quadratics. Today is Section 8.1, Identifying Quadratic Functions. In the past, we've looked at charts and tables, function tables, and we've been able to tell whether or not those functions were linear if we had a consistent change in x and a change in y. If you look at this, you can see that there is a consistent change in x, and the constant changes +1 each time. But if we look at the change in y, we'll notice that the change is not consistent. Therefore, it's not a line. However, if there is a consistent change in the second differences, then we can say that this is a quadratic equation. So we do the first difference, take the second difference, and if the second difference is consistent, we know that it's quadratic. Do these two tables represent quadratic functions? Let's take a look at the first one. For each of those terms, you'll see that they're going up by 1. -4 to a -3 is going up by 1. If you look at the y values, though, the y values are not consistent at all. They went down by 21, then by 15, then by 9, then by 3. But if you look at the second differences are all -6. This table is a quadratic function. You do the next one. You'll see that each of the x's has a difference of 1. And you'll notice the bottom, the y's, they don't have a consistent difference. But if I look at the secondary difference, I can see that they are indeed a quadratic function. So a quadratic function is an equation that written in the form y equals ax squared plus bx plus c. You have a term that has a squared. That's what makes it quadratic. Are these equations quadratic? If so, write them in standard form. And the standard form is y equals ax squared plus bx plus c. How about this one? Is this one a quadratic? And last but not least, if this one's quadratic, write it in standard form. When we graph a quadratic equation, one of the things that we could do is the same that we did for lines when we first started, and that is taking a look at a function table. If I were to look at this equation and I were to substitute in 0 in for the x variable, I would get that y is equal to a -4. Substitute a 1 in, and 1 squared is 1, minus 4 is a -3. Next one, don't be fooled, because a -1 squared is a +1, and 1 minus 4 is a -3. 3 squared is 9. 9 minus 4 is 5. A -3 squared is 9, and 9 minus 4 is 5. Noticing a pattern? If I were to graph this now, you would see that I graphed those 5 points, but you'll notice that they're joined together by a nice soft curve. They have arrows on the end. The function has arrows on the end because it goes on forever and ever like it always did in a line. Same thing happens in a quadratic function's graph. Try these. If I plug in 0, I should get 3. Plug in a 1, I get 1. -1, I also get 1. Think quickly. 2 squared is 4, times a negative 2 is negative 8, plus 3 is a negative 5. Same thing happens with the negative 2. Negative 2 squared is a positive 4, times negative 2 gives you negative 8, plus 3 gives you a negative 5. And your graph looks like this. So when a quadratic function is written in that form, the value of a determines the direction that the parabola opens. A parabola opens upward when a is equal to 0. A parabola opens downward when a is less than 0. Tell whether the graph of the quadratic function opens up or down. Explain. Well, the first thing that I need to do is I need to turn it into standard form. And the a is the coefficient in front of the x squared. So you'll notice that the coefficient, the negative 3, the a, is a negative. Since a is a negative 3 and a less than 0, the parabola will open downward. This problem's a little bit different because the variables are on both sides. You have x's on both sides of the equal sign. So the first thing that we need to do is put it into standard form. So we're going to add 1/3 x squared to both sides. And now we have y is equal to 1/3 x squared plus x minus 3. Does this open up or down? It opens upwards because 1/3, the coefficient, is your a, and a is greater than 0. So the parabola will open upward. Now the highest and lowest points on a parabola are the vertex. If a parabola opens upward, the vertex is the lowest point. If a parabola opens downward, the vertex is the highest point. So this is what that looks like. Here's a parabola that opens upwards. Notice the a in front of here is positive, and because it's positive, the parabola opens upwards. The lowest point is the vertex. That's the point where the curve changes direction. So the lowest point here, the minimum of this, is the vertex. And the vertex is negative 3, 0, but the lowest point, the minimum, is just the 0. Notice that it's the y-coordinate. Likewise, if a is less than 0, the parabola opens downwards, and the y value of the vertex is the maximum. So now look at this example. You have a parabola that is opening downwards, and I know that because I see the negative in front of the x squared, which you know, of course, is also a negative 1. So negative 1 is my a, that's less than 0. That means this parabola opens downward, so the highest point is going to be the vertex. And in this case, the vertex is 3, 5. So my maximum is 5. For this one, identify the vertex of the parabola and then tell me what the minimum is, or the maximum. In this case, because the parabola is opening upwards, I know that I'm going to have a minimum. This is the minimum point. It's the lowest point that it will go in that particular graph. So the vertex should be negative 3, 2, and the minimum is the 2. Now look at this example. This parabola is opening downward. That means that this point is going to be my maximum point. The vertex, the point where it curves, is 2, 5, and the maximum is 5. The last thing we want to talk about is the domain, the range, the vertex, the maximum and minimum, putting it all together. Step number 1. Since the graph opens upwards, we know that we have a minimum, and the minimum is -4. The vertex is -2, -4. Step number 2, find the domain and the range. Now this is time for you to remember that the domain are all the values of x. And since it looks like it's going to go on forever and ever, and it's constantly going to be moving from left to right, we know that our domain is all real numbers. It could be any x. It could be a positive 100. It could be a negative 450. But the range, the y value, you'll notice that the y value is a -4. And it's a closed circle, so again, it's got to be greater than or equal to a -4. You'll notice that there are no points down underneath that graph. This vertex is the lowest point, and everything under here is not a possibility for the range. Let's take a look at this one. Step number 1, the graph opens downward, so we know that this vertex is a maximum. The vertex is 2, 3, and the maximum is 3. Finding the domain and the range, you'll notice again, this is going to be going out and off and on and on and on forever, so the domain is all real numbers. And the range is y is less than or equal to 3. Starting at the maximum, it will be all points going lower. Complete the practice problems and submit them for your homework.